Of all the animals most deformed by consanguinity, it is when incest destroys entire species. This dark history, one that few know, has shaped the fate of entire bloodlines in the silent isolation of rural America's farms. For decades, consanguineous reproduction practices have pushed magnificent species to the brink of functional extinction, burdened with such severe anomalies they challenge our very understanding of nature. Our investigation opens in 1953, within the isolated mountains of western Virginia. Here, the Peterson family managed one of the largest Appaloosa horse properties in the United States. Harold Peterson, the family patriarch and a man of limited vision, firmly believed he could improve the breed through what he termed blood purification, the systematic crossing of closely related animals to preserve desirable traits. At that time, knowledge of genetics was extremely limited among rural breeders, explains Dr. Leonard Mitchell, historian of veterinary medicine at Cornell. Many believed crossing close relatives would intensify the animal's best qualities, completely unaware of the devastating biological consequences. The Peterson property lay more than 30 kilometers from the nearest town, nestled in a valley surrounded by densely wooded mountains. This geographic insulation provided Harold the perfect environment to conduct his experiments without supervision or interference. Few visitors were permitted, and veterinarians were rarely summoned, even when necessary. In the early years, the results seemed promising. Peterson Farm's Appaloosa horses displayed stunning coat patterns, with unique spots that attracted buyers willing to pay high prices. But behind this apparent aesthetic perfection, a silent tragedy began to unfold. By 1958, the first foals with visible anomalies were born. Atrophied front legs, abnormally small eyes, and mandibular deformities were just the beginning. Harold, however, dismissed these as isolated birth accidents and continued his practice, now crossing animals that were themselves the products of consanguineous unions. What we see in the surviving veterinary records from that time is alarming, says Dr. Elaine Harris, a geneticist specializing in veterinary medicine. The notes from the only vet who visited the farm in 1960 described foals with such compromised immune systems they succumbed to common infections within days. Some were born with exposed organs or had severe heart defects that prevented them from surviving more than a few hours. The situation deteriorated rapidly between 1960 and 1963. Adult horses began exhibiting abnormal behaviors. Some grew inexplicably aggressive, while others developed repetitive movement patterns, shaking their heads incessantly or walking in circles for hours. Mares found it increasingly difficult to conceive, and when they did, they often suffered miscarriages or delivered stillborn foals. The case of the Peterson horses might have remained just another sad, undocumented episode in the history of American animal breeding were it not for Raymond Foster, a young National Geographic photographer who visited the region in 1964 for a project on the Appalachian Mountains. Foster arrived at the property by accident when his Jeep broke down nearby, says John Harrison, a local historian and author of Secrets of Rural Breeding, The Unlisted Stories. What he witnessed would forever change our understanding of the effects of consanguinity on animal populations. The photographs taken by Foster, though never published by the magazine due to their disturbing nature, documented the result of 11 years of systematic inbreeding. Horses with deformed skulls, misaligned jaws that prevented proper nutrition, atrophied limbs, and skin with areas completely devoid of hair. The most haunting features were the eyes. Many animals had microphthalmia, a condition where the eyes are underdeveloped, or anophthalmia, the total absence of eyes. What Foster documented was the complete collapse of a genetic lineage, says Dr. Paul Whitman, a geneticist at the National Institute of Animal Health. Records indicate that by the time of Foster's visit, approximately 78% of adult animals had some visible deformity, and the full mortality rate had reached almost 90%. Harold Peterson, however, seemed unable to recognize his own responsibility. In personal diaries discovered after his death, he attributed the problems to external forces, from water quality to alleged radiation from nuclear tests in the West. He never considered that his own breeding practices were the cause of the disaster. Check to see if you're already subscribed to this channel so you don't miss any of the stories that reveal the darkest secrets of human intervention in nature. These are truths few have the courage to face, but we all need to know them to avoid repeating the same devastating mistakes of the past. When veterinary authorities in Virginia finally intervened on the Peterson property in March 1965, they found a situation even more grave than Raymond Foster's photographs had suggested. Of the 143 horses originally recorded, only 67 remained alive. And of those, only 12 were in a condition considered acceptable by basic animal health standards. The official report contained descriptions that shocked even the most experienced veterinarians, explains Dr. Margaret Wilson, who accessed the state archives during her research for the Agriculture Department. There were horses with duplicated organs, incomplete digestive systems, and skeletal deformities so severe the animals could barely stand. One of the most iconic cases documented was that of Midnight Star, a 4-year-old stallion who had been the pride of Harold Peterson. The animal, the product of 5 generations of inbreeding, had a black coat with perfectly symmetrical white spots, a characteristic for which Peterson had intensively selected. However, Midnight Star suffered from a rare cardiac condition. His heart had only 3 functional chambers instead of 4, causing the animal to live in a constant state of hypoxia and fatigue. The case of Midnight Star perfectly exemplifies the fundamental problem of intensive consanguinity, says veterinary geneticist Dr. Thomas Reynolds. Harold selected only for the visible characteristic of the coat, without understanding he was simultaneously concentrating deleterious recessive genes that would normally remain hidden in diverse populations. The science behind this disaster is complex but fundamentally clear. When closely related animals reproduce, the probability that offspring inherit 2 copies of the same gene increases dramatically. If these genes carry harmful mutations, something common in all species, the result is the manifestation of diseases and anomalies that would normally remain latent. In healthy populations, these harmful genes are diluted by genetic diversity, explains Dr. Harris. Think of it as a deck of cards. If you have a complete deck, the chance of drawing a specific card is small. But if you remove most cards, leaving only a few suits, your chance of repeatedly drawing the same card increases exponentially. This is what happens with problematic genes in inbred populations. Laboratory tests on the surviving horses revealed alarming levels of homozygosity, the condition where an organism has identical copies of a gene on both chromosomes. While healthy horse populations typically show homozygosity rates between 3% and 10%, the Peterson animals displayed rates between 42% and 68%. With such homozygosity levels, it wasn't a matter of if genetic problems would appear, but how many and how severe they would be, says Dr. Whitman. The immune system, embryonic development, metabolism, all fundamental biological systems were compromised. The effects of inbreeding were not limited to physical deformities. Veterinarians noted deeply disturbed behavioral patterns. Mares systematically rejected their foals, an extremely rare behavior in healthy horses. Other animals exhibited self-directed behaviors, biting their own flanks until causing serious wounds or repeatedly hitting their heads against stall walls. What we were observing was the collapse not only of the physical body, but also of neurological systems, explains neuroscientist Dr. James Bradford, who later studied preserved brain tissue samples from the Peterson horses. Post-mortem analyses revealed significant malformations in the hippocampus and other brain structures crucial for instinctive behaviors and emotional regulation. One of the most tragic aspects was the prolonged suffering imposed on the animals. Harold, unable to recognize his practices were the cause, refused to euthanize even the most severely affected horses. Records indicate many deformed animals were kept alive for years, unable to perform basic natural behaviors like running, grazing properly, or interacting normally with others of their species. The Peterson case was not only a genetic disaster, but also a monumental ethical failure, says veterinary ethicist Dr. Elizabeth Morgan. By prioritizing his distorted vision of purity over animal welfare, Harold created a living hell for those creatures. Investigations revealed Peterson had systematically falsified genealogical records to sell inbred foals as if they were from diverse bloodlines. Between 1955 and 1963, he sold approximately 200 horses to farmers in at least 12 different states, spreading compromised genes through a significant portion of the national Appaloosa genetic pool. The impact of the Peterson case extended far beyond that isolated property, explains Dr. Mitchell. For decades after the intervention, Appaloosa breeders across the country continued to discover genetic anomalies that could be traced back to Peterson's animals. Some of these mutations persist in the breed to this day, albeit at much lower frequencies thanks to deliberate genetic diversification efforts. While the tragedy of the Peterson horses unfolded in the mountains of Virginia, an equally alarming, though less documented, situation was occurring in Clearwater County, Idaho. There, in the dense forests bordering the Clearwater River, an isolated community of hunters perpetuated breeding practices that would have devastating consequences for generations of dogs. The history of the Clearwater dogs remained largely unknown until 1971, when a recently graduated veterinarian, Dr. Sarah Jenkins, accepted her first job in the region. What she found would transform her career and our understanding of the effects of inbreeding on domestic canids, says Michael Stevens, author of Lost in Forests, The Forgotten Northwest Communities of America. The Clearwater community had been established in the 1920s by families seeking distance from growing urban development. Living off hunting, fishing, and subsistence agriculture, they developed their own culture deeply connected to the natural environment. Central to their subsistence was hunting, for which they heavily relied on specialized dogs. Over the decades, they developed what they called the Clearwater Hound, which local residents claimed had superior tracking skills, especially for bears and large cats. The exact origins of the Clearwater Hound are foggy, explains canine geneticist Dr. Robert Thompson. Fragmented records suggest an initial mixture of bloodhound, plot hound, and possibly American foxhound. What is certain is that from approximately 1940, the region's dog population became extremely endogamic, with new genes rarely introduced. The community, proud of its local dogs, firmly resisted outside bloodlines. A notebook found in the cabin of Elmer Jenkins, one of the most respected breeders in the region, revealed a detailed system of crosses that explicitly favored breeding between siblings, half-siblings, and cousins. When Dr. Sarah Jenkins arrived in 1971, she found a canine population in advanced genetic collapse. In her professional diary, later published in the Journal of Veterinary Ethics, she documented, "Clearwater's hunting dogs show the most alarming set of congenital anomalies I have ever witnessed. Approximately 60% of puppies are born with cleft palates, while almost 80% develop severe hip dysplasia before age 2. The most disturbing trait is what the locals call clear eye, a condition where the eyes are progressively covered by an opaque membrane, leading to complete blindness around age 4. Upon detailed examination, Dr. Jenkins found that virtually all 287 dogs in the community could trace their lineage back to just 6 founding animals from the 1930s. The coefficient of inbreeding reached astronomical values of 43% to 51%, values above 10% are already considered worrying in canine populations. With each generation, the conditions worsened, Dr. Jenkins documented. Litters where more than half the puppies had cryptorchidism, failed testicle descent, spinal deformities, and severe heart malformations. Even more alarming was the rising incidence of abnormal behaviors. Younger dogs exhibit deeply disturbed behavioral patterns, she wrote. Many develop compulsive fixations, such as chasing their own tails incessantly or licking certain objects until they cause wounds on their tongues and gums. Cases of sudden and unpredictable aggression have become common, even in previously docile animals. More worrying is the growing tendency of mothers to reject, or in extreme cases attack, their own puppies. I witnessed the empty look in these animals' eyes, carrying the genetic weight of decades of wrong choices. If you are watching and share my sense of indignation, leave a comment. Nature deserves respect, not interference. We need to make this message echo so that stories like these are not repeated. Despite the scientific evidence presented by Dr. Jenkins, the community initially resisted her recommendations to introduce genetic diversity. Elmer Jenkins, then 76 and considered the foremost local authority on dog breeding, argued that diluting the blood of the Clearwater dogs would destroy their special hunting abilities. What we see here is a recurring phenomenon in cases of inbreeding, says Dr. Morgan. Often, breeders develop almost mystical beliefs about the purity of their lines, attributing extraordinary abilities to animals that are actually severely compromised. It is a form of circular thinking where any distinct feature, even deficiencies, is interpreted as proof of exceptionality. The situation reached a critical point in 1973 when a particularly affected litter was born on a central community property. Of the 9 puppies, 7 were born with partial anencephaly, a fatal condition where parts of the brain and skull fail to develop. The 2 survivors developed such erratic and dangerous behaviors they had to be euthanized before reaching 6 months. This event finally broke the community's resistance. With the reluctant permission of local elders, Dr. Jenkins implemented a genetic rehabilitation program, gradually introducing healthy external bloodlines while maintaining meticulous kinship records to avoid new inbreeding. Dr. Jenkins's program represents one of the first documented genetic rescue efforts in a canine population, says Dr. Thompson. Her meticulous notes on the recovery process provided a model later used in several similar cases worldwide. The genetic recovery process was long, methodical, and often frustrating. Dr. Jenkins faced not only biological challenges but also persistent cultural resistance from the oldest community members. Her professional diary reveals the complex dimensions of this work. April 1974. Today I witnessed something that gave me hope for the first time in months, Dr. Jenkins wrote. Ruby's litter, the result of an outcross with a bloodhound brought from Boise, produced 7 puppies, all seemingly free of the cranial malformations that have become almost universal here. More significantly, I saw Elmer Jenkins, the most resistant to my intervention, smiling as he watched the pups suckle vigorously, a rare behavior in recent litters. A small step, but perhaps a turning point. The recovery strategy had 3 main components: the controlled introduction of new breeders, genetic mapping to avoid new inbreeding, and rigorous monitoring of physical and behavioral traits. Dr. Jenkins's approach was notably sophisticated for the time, says conservation geneticist Dr. Catherine Miller of the University of Colorado. Without modern genetic sequencing technologies, she created a diversity score system based on observable characteristics and known genealogy. She was practicing advanced population genetics using only clinical observation and meticulous records. Over the first 2 years, 14 outbred dogs were carefully introduced, selected to preserve functional traits valued by the community, like a keen sense of smell and physical endurance, while diversifying the genetic pool. Dr. Jenkins insisted on detailed records for every birth, thoroughly documenting physical characteristics, exam results, and behaviors. The initial results were encouraging but not without complications. The 3rd generation of crosses showed a significant reduction in the most serious physical anomalies, with the incidence of cleft palates falling to around 12% from the previous 60%. However, behavioral problems persisted, particularly tendencies toward hyperactivity and socialization difficulties. The Clearwater case taught us a crucial lesson about genetic recovery, explains Dr. Thompson. Some traits, particularly those related to complex neurological and behavioral systems, can remain compromised for generations after initial diversification. This is because many behavioral traits are polygenic, controlled by multiple genes that can stay compromised even after initial interventions. A particularly challenging moment occurred in the winter of 1976 when a severe snowstorm isolated the community for almost 3 weeks. During this period, 2 of the main outside breeders died in an accident when a shed roof collapsed under the weight of snow. This event threatened to reverse progress but also demonstrated the community's growing commitment to the program. February 1976. I was genuinely moved today, Dr. Jenkins recorded. After losing Rex and Sadie in the collapse, I feared we would backslide out of necessity. Instead, Thomas and Gerald Jenkins, Elmer's nephews, traveled 42 miles through the snow to reach the nearest phone and contact breeders in Lewiston. They returned 5 days later with 3 new unrelated dogs. The community met to cover the substantial acquisition costs. The old ways are dying with us, said Gerald, but the new ones will live with our children. By 1980, the results were undeniable. The Clearwater canine population had grown to roughly 350 animals, with inbreeding coefficients reduced to an average of 8.3%, still high by ideal standards but dramatically better than the 47% average recorded in 1971. More importantly, the dog's functionality as hunting companions had not only been preserved but significantly improved. What the Clearwater community discovered to its surprise was that the new dogs were superior hunters, says Stevens. With better vision, greater physical endurance, and more stable behavior, they consistently outperformed the remnants of the old lines in all practical aspects of hunting. This was probably the most convincing factor for the most skeptical members. The clear-eye dystrophy, which had previously condemned almost all dogs to progressive blindness, had become relatively rare, affecting less than 5% of the population. Severe skeletal anomalies were reduced to levels comparable to those of normal canine populations. More significantly, abnormal behaviors like self-harm and impulsive aggression had decreased dramatically. Dr. Jenkins's work in Clearwater was finally published in the prestigious journal Genetics and Animal Conservation in 1982, bringing international attention to the case. Her article, Genetic Recovery in Isolated Canine Populations, the Clearwater Model, became essential reading in veterinary medicine and genetic conservation programs. The most important legacy of the Clearwater case was not just the dogs saved in that specific community, concludes Dr. Miller. It was the practical demonstration that populations severely compromised by inbreeding can be recovered with methodological and patient intervention. The principles established by Jenkins have since been applied everywhere from work birds on the brink of functional extinction to wild populations isolated in fragmented nature reserves. This scientific legacy, however, does not diminish the reality of the suffering experienced by animals during the decades before the intervention. As Dr. Jenkins herself wrote in her final reflections, every documented malformation, every observed abnormal behavior, represents a sentient life experiencing unnecessary pain and confusion. True triumph will be when such interventions become unnecessary because we finally understand that diversity is not just statistically desirable, but ethically imperative. While the cases of the Peterson horses and Clearwater dogs may seem like relics of a less enlightened past, the uncomfortable truth is that similar practices continue in various contexts of contemporary animal breeding. The lessons of these historical cases remain painfully relevant in the 21st century. The phenomenon we see today is more insidious because it often hides under the cloak of preservation or breed purity, explains Dr. Elena Rodriguez, an expert in animal welfare and breeding ethics. One of the most emblematic modern cases involves the English Bulldog, a breed whose genetic pool has become so restricted that recent genomic studies suggest its current diversity is equivalent to what would exist if only 68 unrelated dogs had founded the entire modern breed. The modern Bulldog is essentially a walking warning about the dangers of inbreeding, says Dr. Whitman. Virtually all suffer from severe brachycephaly, leading to chronic breathing problems so serious many airlines refuse to transport them due to the risk of death during flight. Over 80% require cesarean sections for birth because selection for large heads and wide shoulders has made natural birth impossible. The genetic consequences of inbreeding are not limited to specific breeds. In the dairy industry, the situation is particularly alarming. A 2019 study revealed that 99% of Holstein bulls used for artificial insemination in the U.S. can trace their lineage back to just two founding animals from the 1960s. The situation of Holstein cattle is a perfect example of how economic pressures can accelerate genetic disasters, says Dr. Frank Anderson, an expert in production animal genetics. The intensive selection for milk yield has resulted in cows that produce impressive quantities, over 30,000 liters per lactation compared to 5,000 from a typical 1950s cow, but with devastating consequences for longevity, fertility, and welfare. Modern Holsteins typically survive only 4 to 5 years in production, compared to a natural lifespan of 15 to 20 years. Fertility problems have become so common that many farms consider it normal for a cow to need 3 to 5 inseminations to conceive, when historically 1 or 2 were sufficient. We are witnessing a form of genetic extremism, continues Dr. Anderson. We are essentially creating animals that are efficient short-term milk production machines but fundamentally dysfunctional as complete biological organisms. The case of show Arabian horses represents another worrying contemporary example. Selection for extreme facial characteristics, particularly the concave profile known as a dish face, has resulted in a population where neurological, respiratory, and dental problems are common. Some Arabian horses winning major shows today have such extreme cranial malformations they would have been considered severe deformities just 50 years ago, explains Dr. Wilson. We see animals with nostrils so small they dramatically limit respiratory capacity, and facial profiles so concave they result in chewing problems and dental malocclusion. All in the name of an aesthetic standard pushed to the extreme. Perhaps even more disturbing is the silence that often surrounds these problems. Breeders, show judges, and breed associations often minimize or ignore the genetic consequences of these practices, focusing exclusively on the aesthetic traits valued in the competition circuit. There is a conspiracy of silence in the world of animal breeding, says Dr. Howard Bennett, a veterinarian and former dog show judge who has become a vocal critic of modern practices. Behind the scenes, everyone recognizes the problems. We see puppies that die from heart malformations, adults that can barely breathe, and animals that develop devastating neurological conditions. But publicly, we continue to reward the most extreme specimens, perpetuating the cycle. In the context of wildlife and conservation, the lessons of Peterson and Clearwater take on added importance. When populations of threatened species are reduced to critically low numbers, the risk of inbreeding depression becomes a significant challenge. The case of the cheetah, Acinonyx jubatus, dramatically illustrates this. Genetic studies show the global population has passed through at least two severe genetic bottlenecks, periods when numbers were so low that genetic diversity was drastically reduced. Modern cheetahs have such limited genetic diversity they are practically immunological clones of each other, explains conservation biologist Dr. Samantha Lewis. This means a single infectious disease could potentially decimate the entire population, as all individuals share the same immunological vulnerabilities. It is like having a human population where everyone has the exact same blood type and allergies. This genetic homogeneity manifests in alarming reproductive problems. Over 70% of male cheetah sperm shows morphological abnormalities, and semen quality is consistently poor. Females often produce small litters, and cub mortality is significantly higher than in species with greater genetic diversity. What we see in the cheetah today is the result of natural inbreeding forced by population reductions, continues Dr. Lewis. But the worrying thing is that we are deliberately creating similar situations in captive populations of other threatened species when we fail to manage genetic diversity adequately. The irony is that while the negative effects of inbreeding are well documented and scientifically understood, practices that promote genetic homogeneity continue to prevail across various animal breeding contexts. This disconnect between knowledge and practice represents one of the greatest challenges for animal welfare in the 21st century. We know better, but we often don't do better, says Dr. Rodriguez. Historical cases like Peterson and Clearwater should serve as powerful warnings, but instead we often repeat the same errors on even larger scales, now aided by advanced reproductive technologies. Artificial insemination, for example, allows a single sire to produce tens of thousands of offspring, something impossible through natural reproduction. When that sire carries problematic genes, the negative impact is exponentially amplified throughout the population. In the age of reproductive biotechnology, the risks of genetic homogeneity are even greater, warns Dr. Whitman. A popular dairy bull may have its semen distributed globally and produce over 100,000 offspring. If we later discover it carries a harmful genetic mutation, the damage is already disseminated across multiple generations and geographies. The fundamental question emerging from these historical and contemporary cases is one of ethics, responsibility, and our relationship with other species. Intensive inbreeding represents a form of human interference in the fundamental biology of other creatures that often results in unnecessary suffering. What the cases of Peterson and Clearwater teach us above all is about humility, reflects Dr. Morgan. They remind us that interfering with the basic evolutionary mechanisms that maintain population health often has unintended but profoundly harmful consequences. Genetic diversity is not a luxury or an abstract preference. It is the foundation of health and biological functionality. There are, however, encouraging signs of change. In 2019, the UK Kennel Club implemented new guidelines for breeders of English bulldogs, French bulldogs, and pugs, aiming to reduce extreme brachycephaly in these breeds. Outcrossing programs have been started for particularly compromised breeds, carefully introducing genetic material from related breeds to expand the gene pool without losing essential defining characteristics. The Outcross for Dalmatians program is an excellent example of how we can address genetic problems without abandoning the concept of defined breeds, explains Dr. Thompson. By introducing a single cross with a pointer, followed by generations of pure Dalmatian breeding, they addressed a widespread metabolic issue without losing the breed's identity. In wildlife conservation, sophisticated genetic management strategies are being implemented to maximize diversity in small populations. The Mexican Wolf Recovery Program, Canis lupus bili, for example, uses advanced genomic analysis to determine ideal pairings between captive individuals, maximizing the retention of genetic variation. We are finally recognizing that preserving numbers alone is not enough, says Dr. Lewis. We need to preserve functional genetic diversity if we want these species to survive long-term. A purely numerical success that results in a genetically compromised population is not true conservation success. As we advance into the 21st century, the lessons of Peterson and Clearwater remain fundamental to our understanding of ethical responsibility in animal breeding and conservation. These stories remind us that our power to shape other species through reproductive selection carries with it the obligation to understand and respect the fundamental biological principles that underpin health and welfare. The true legacy of these cases is not only in the suffering they documented, but in the lessons they offer, concludes Dr. Rodriguez. They show us that respect for biological integrity and genetic diversity is not only scientifically sound but ethically imperative. Our interventions in animal reproduction should be guided not just by aesthetic or productive goals, but by a fundamental commitment to the welfare of the animals under our care. If you've watched this far, it is because this story resonated with you. Leave a comment saying, "I watched here," so I can get to know you and see who truly appreciates the stories here on the channel. Be sure to subscribe to follow our investigations that reveal the darkest and most educational truths about the impacts of human intervention on the animal world. Leave your like to support this work of awareness, and share it with friends and family who need to know these important stories about the consequences of animal inbreeding. Together, we can promote a future where respect for genetic diversity and animal welfare guides our breeding and conservation practices.